All right, last example from section 5.2. What you record matters as much as the random event. So a family is planning to have 3 children. You're going to record the gender of each of the 3 children's in birth order. B for boy, G for girl. Find the sample space, are the outcomes equally likely, and create a probability model for the situation. So we're going to record the order of our boys and girls. So we'll call this outcome. We're going to make a probability model, so let's just start with the table. So I could get 3 girls in a row, girl, girl, girl. I could get 2 girls and a boy. Let's do all the combinations of 2 girls and 1 boy. I could get a girl, boy, girl. I could get a boy, girl, girl. Now let's do all the combinations of 1 girl and 2 boys. I could go girl, boy, 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 girl, boy, 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 girl. And I could get 0 girls. I can get all boys. And then the probability of those outcomes. So the question is, are these equally likely? Well, they are equally likely. Why are they equally likely? Well, I guess any combination of boys and, any combination of boys and girls should be equally likely from any other combination of boys and girls. Basically, the probability of getting a boy or a girl is the same. So by symmetry, I guess, it doesn't matter, whether you get the boy first or the boy second. And for that matter, it doesn't matter whether you're getting boys or girls at all. Any one combination of boys and girls should be equally likely than the other. I can actually answer this a little bit better in the next section when we learn how to do ands and we learn the multiplication rule. But for right now, I think that should be a sensible argument. Symmetry, I guess. When in doubt, symmetry for a reason, right? So if there's 8 outcomes and they're equally likely, then their probabilities are simply 1 out of 8 for all of them. Okay, so now same random phenomenon. We're planning on having 3 children. Now though, you're going to record the number of girls the family has. So our outcomes are going to be the number of girls. You could get 0 girls, you could get 1 girl, you could get 2, but you're only having 3 kids, so the most you can get is 3. And then what are the probabilities of these outcomes? So these are not equally likely. The reason is, as you can see from above, there are multiple ways of getting. Let's look at the instance where we're getting 1 girl. There are actually 3 different ways to get 1 girl. There are 3 different ways to get 2 girls. However, there is only 1 way to get no girls, and there is only 1 way to get no girls. Sorry, all girls and no girls. So these aren't equally likely. They're not just 1/4, 1/4, 1/4. Why? I don't have a good argument for it. I mean, I don't have an argument for why these should be equally likely like I kind of did up here. So what's the probability of getting no girls? Well, that's 1 out of 8. What's the probability of getting 1 girl? Well, that's 3 out of 8. 3 out of 8, 1 out of 8. Okay? And the answer to this question is, are these outcomes equally likely? The answer is, they are not. Okay?